there was some technical error. Sorry for the inconvenience. So what we were talking about was the chirality and biology, and we have already related it with how we can find out the whether the molecule is chiral or not on the basis of the pointers. But on the biology, we mean to say, like, why are we looking for the chirality? Because our system, that proteins, carbohydrates, DNA, RNA systems, nucleic acids, they all belong to this category. And how it helps it, because they have a kind of lock and key mechanism. Say, for example, our proteins, mainly the building blocks is amino acids. So they are chiral in nature. And how it works, lock and key mechanism. Say, for example, if we have this kind of thing, and we have now 3 targeted molecules. So this is my log. Only this key is going to fit in this space. These two will not. So for every log, there is 1 key. That is the way lock and key mechanism works, and it helps in many understanding of many mechanisms which are happening at the enzymatic level or the biological level. So these are the basics that you can go back and read or learn from the videos. But today we will mainly focus on this amino acids and to name them, because this would give you a lot of questions directly into the exam. Now, firstly, the amino acids that we are aware of. So actually, protein is a polymeric chain of these amino acids. So generally they exist in L-alpha amino as alpha amino acids in nature. So the basic structure of your amino acid is, there would be a chiral center, carbon, having an R group, which could be anything. The carboxylic group, because we are talking about the amino acid, NH2, and hydrogen at the back. So for giving the L and D form, this is anti-clock rotation, this is clock rotation, and our existing amino acids are mostly in L form. So we will see that which rule could be made. Rule to assign L and D forms. So con is the rule. So from the carboxylate, if you are going to the R group and then to the NH2 group, if it is clockwise, that is a D form. If it is anti-clockwise, then it's a L form. Say, for example, I am taking this general R group, keeping thing in mind that H is at the back, not at the front, this way. So now this is con. You have to start with this one. This is named as 1. Then R is named as 2. Then NH2 is named as 3. Now, if you'll see the direction, that 1, 2, 3, it is going anti-clock. direction is opposite. So therefore, this is a L form, L amino acid. Whereas, if we will be having C, R, so 1, 2, 3, in this particular form, that is clockwise, it will be a isomer. Now we will talk about the different types of amino acids and their 3-letter, 1-letter codes. So today's problems we have already seen, and most of the things would only come from this amino acid in this particular week. So if you guys would be having any issue, you can let me know in the next live session. But today we will be more focusing on its naming so that you will be understanding that naming of the amino acids is required to understand the circular dichroism in the later point of time. So we will start. Generally, we have certain classes of it, which are aliphatic, aromatic, acidic, basic, polar, sulfur containing, amine containing groups. So 6 classification we have basically in amino acids. So one is aliphatic, second one is aromatic, third is polar, fourth one acidic, fifth is basic, sixth is sulfur containing. So as the name itself suggests that whether it is what kind of groups would be present in there. For example, if I talk about the aliphatic group, it would mainly be comprising CH3H, CH3 isopropyl group or something like that, etc. If aromatic is there, that mostly be having the aromatic groups, phenyl, indole, etc. Acidic would be having more COOH, basic would be having more NH2 in that. Sulfur containing would definitely be having sulfur moiety inside. Polar, that means they are creating the polarity of the molecule. So their names have been given based on the kind of R group is being attached. So we are mainly because basic that basic structure of the amino acid, which is having a COOH and NH2 and H. This is not going to change. This is your basic moiety. Whereas this R, depending upon R is aliphatic, R is aromatic, acidic, basic, sulfur containing. So it gives you what polarity it is making. So it will give you different names. So we will first take the aliphatic amino acids. And there we will be having, there are name, 3-letter, I'm just writing like this way. one letter code. These are the codes. So first one we have if R is just your H. If R is equals to H, then the name is given as glycine. And this is the only one which is not chiral. Why it is not chiral? Because for chiral, we need to have no plane of symmetry, no invergent center, nothing at all. And the groups also has to be different. So here, carbon, here would be H, the other H is already. So it is having two same centers. So some kind of symmetry would be existing besides CN and that. So therefore, there is no chirality. Whereas three-letter code for glycine is GLY and one letter is G. If you have, I will not be making the table again, so just keep that thing in mind. R is equals to CH3, like one group is there, that means the structure would be CH3, here H, NH2, COH. Here also if you see 1, 2, 3. This is anticlock, so it is L isomer. The name it is given as alanine, which has been written as ALA, and the short form is A. The third one that we have is CH3, CH3. That's an isopropyl group. And it gives you a name of valine, which is written as Val and sign as. Okay. So now we have covered three, glycine, alanine, and valine. Now the next one is fourth one we have. It is having one more CH2 along with the isopropyl group. So it is called as leucine, LEU and L. Then fifth one that we have is CH3. Now the substitution is happening at this level, CH2 and CH3. If this is having an extra CH2 with the isopropyl, that is leucine. Other one was valine. And here, if this is a 3-center chain and substitution is happening at the third position, so it is giving you isoleucine. Because if you will count the number of carbons over here, both are same. But here it's a chain where the third position is getting substituted with this methyl. So isoleucine, ILE and capital I. So these aliphatic amino acids are hydrophobic in nature because they are only having the carbon-hydrogen bond. So we can write over here. So these aliphatic amino acids are hydrophobic in nature. So these 5, which was glycine, having only H, alanine with CH3, valine with isopropyl group, leucine with CH2 and isopropyl group, and isoleucine having CH2, CH3, CH, CH3, and this is connected from this way. So these are the aliphatic. Now we will look into aromatic ones. So in the aromatic amino acids, we have mainly three types only. Where aromatic is there, so there would be an aromatic group. So the first one we have is this aromatic group with CH2 connected, and this CH2 is your R group. The name is phenylalanine. Nothing to mug it up, because this simple CH3 was your alanine, and now phenyl is being attached. That's why it becomes a phenylalanine. The three-letter code is PHE, and one letter is F, not P. So be very careful when you are writing these. Earlier, what we saw that for glycine it was G, G to G. For alanine, A to A. For valine, it is V, and then leucine, it is L. Isoleucine, it was I. So don't get confused that, okay, phenylalanine starting with PHE, it should be P. No, it can't be P, it is F. The second one we have is, I hope you guys know about the indole system. There is a 6-member ring connected with a 5-member ring, and it is having CH2 over here, which is your R group. So this part is your indole. That is, the whole amino acid is called as tryptophan. And it is written as TRP. Here also it starts with W. So this is also very important. The third type that we have is, we have a phenol group, and para to it there is CH2, which is your R group. So this is a phenol moiety. The name is tyrosine, TYR and Y. So here we have to remember that phenylalanine, the code is F. Tryptophan, TRP, not TRY, it's W. And tyrosine, it's Y. FWY. These are the aromatic groups. Now we will see the polar groups. The third type that we have is polar amino acids. The first that we have, simple CH2OH. It's a primary alcohol. Name is serine, short form SER. One letter is S. The second one, now here it would be having OH. So it becomes a secondary alcohol. Name is threonine, THR, letter T. Third is CH2, C double bond O, NH2, amide group, S. asparagine, ASN, and N is the letter. So whatever I'm highlighting here, this one, these things are important. So if one is there, then CH2 primary, serine. If secondary alcohol is there, threonine. And if amide group is connected to CH2, that is asparagine. One more is there. Asparagine was having one CH2 only. It is having two. So it is called as glutamine with GLN and Q. Again here, the code is GLN, but the name is the one letter code is Q. Now, we come to acidic. So D are acidic amino acids. So besides the acidic group present, there would be additional acidic. So two groups are there. One is CH2, CO, which this is an acid one group called as aspartic acid, written as ASP, symbol is D, highlighted. Second one is having one more CH2, called as glutamic acid. You can see that glutamine and glutamic both are having 3 number of carbons, written as GLU, glu, and E. Please remember the symbols. So these are the acidic ones. Now we will see the basic ones. Basic amino acids. So the first one that we have is so since acidic were having COH group, they would be having additional NH2 group. So CH2, 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 NH2, 4 carbon chain called as lysine, Lysine. Code is Lys and written as K because leucine we have already given the code L. Now it can't be same for the another amino acid. And the second one is CH2, 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 NH, C, double bond NH, NH2. So the carbon number remains same. 2 additional NH groups are involved. It is called as arginine, written as ARG and R. Since alanine has already been given A code, so arginine is given as R. And the third that we have here is CH2, NH, N. So this group is imidazole, and this whole group becomes histidine. Code is this, letter is H. So these are your basic amino acids. We're having the more than one NH2. Now the last category, sulfur containing amino acids. So first is CH2 acid, simple thiol group. It is called as cysteine. If you will be remembering that CH2 OH was CV, here SH is cysteine, given the code as CYS and letter C. Then we have CH2, CH2, S, CH3 is called as methionine, MET and M. The last one that we have is CH2, SCH. This is containing selenium rather than sulfur, SEC, and symbol is U. And the 20th amino acid that we have is proline, because that is a secondary amine. So proline is a secondary amine and not it's a and it is directly connected NH, which is 2 degree. Earlier ones were having NH2 separately, so it is named as Pro and P. So these are the 20 amino acids that we talked about. So the only thing is the chirality. We are dealing with the biological systems, proteins, carbohydrates, enzymes, and something. And they have a property for the molecular recognition, which helps in the antibacterial activities or something. And for that, lock and key mechanism is there. The basic chain of the protein is amino acid that we have seen 20 number, and aliphatic, aromatic, basic, acidic, sulfur containing, selenium containing, that all we have gone through. So all the questions will be coming from this particular thing only. So for example, the question can be asked like, if among the following amino acids, which one belongs to the acidic group? Say for example, the question is, which of the following amino acids belong to aromatic class? So the option can be ALA, can be F, W, L. So we already saw that Al is alanine, which is having CH3. So this can't be. F is our phenylalanine, CH2PH. This is W is our tryptophan, CH2. Tryptophan, which is having W, so it is there. And this is leucine, which is having CH2 with isopropyl group. This is option. So only option B and C are the correct. So in this manner only you will be getting questions in your exam. So second question could be so for this example, we have already talked about that rule is CO, R, and con. Firstly, the carboxylic group, then your R group, then your amine group. So you have to go into that direction that it should come as 1, it should come as 2nd, it should come as 3. So if 1, 2, 3, 2, 2 to 3 is clockwise, that is your D. If it is anti-clockwise, that is L. So we need to find the L amino acid. Now here, keeping your H at the back, so H is at the back, this dash bond is showing it. Now give the number carboxylic to 1, this is 2, this is 3. Now going from 1 to 3, it is anti, therefore it is L. Here again this is at back. Now this is 1, this is 2, this is 3, no, this is a D form. So this way the question will be coming, and we have covered mainly the amino acid part from the week 3 lectures, which is important. The rest of the things regarding the biology and chirality will be discussed in the next live session, which is on Saturday, tomorrow, from 7 to 9 p.m. So besides this, if anybody is having any question, you can unmute yourself or put a question in the chat box. I'll be happy to answer it. And all these slides would be uploaded in the folder, the drive, and you can access it. You can also mail me at the given email ID for any questions when you are going through the lectures. Thank you.